Hey everyone, today we are working through our math lesson 12-4. We're going to begin today by looking at the solve and share. So here is the situation. The mural is divided into 100 equal parts. Marilyn's class painted 3/10 of the mural, and Cal's class painted 27/100 of the mural. How much of the mural have the two classes painted? Solve this problem any way you choose. So the first thing that we're going to do together is we are going to color in the diagram to represent the situation. Our first quantity in the solve and share is 3/10. So in the diagram, we're going to color in 3/10. So I'm going to mark off, and just to save time, I'm going to do dots instead of shading the whole thing in. There's 1/10 and 2/10 and a third tenth. So notice I colored in 3 full columns. Each of those columns has 10 pieces in it, which is why that represents 3/10. I'm going to change colors. You do not have to, but I'm going to do that just so you can see the next piece. The second quantity that we have here is 27/100. So I'm going to color in another 27 of these blocks. So I know in 27 there's 2/10. So I'm going to color in 2 full tenths. So far that's 20. Then I'm going to color in 7 more. 1, 2, 3, 4, 5, 6, 7. So in this green section here, I have colored in 27/100. Now, to find the total amount of the mural the two classes have painted, we could simply just count everything that we've shaded. You can see here 1/10, 2/10, 3/10, 4/10, 5/10. And then another 7 in this column gives us a total of 57 out of 100 parts. However, when you're working with these fractions, you don't often have these diagrams available to you. So what we're going to learn in this lesson today is how do you do the computation piece to solving this kind of a situation so you don't need these diagrams. So what we're actually going to be doing is we are going to be using equivalent fractions and then adding fractions. So here's what this would look like. We have learned in math class that you cannot add fractions unless they have a like denominator. So if we were to try and add these fractions right now, we can't do it because the denominator of 10 and the denominator of 100 don't match. So the only way that we could add these is for them to have the exact same denominator. So what we're going to do in these situations is take our quantity that is written in tenths, and we are going to turn it into hundredths. And this is why we spent time last week going back and reviewing how tenths and hundredths can represent the same amount. So notice, if we focus here on this purple section, yes, that is 3 full tenths, but we also know that that is the same thing as 30 out of 100, or 30 hundredths. 10 in the first column, 20, and then 30. So all we really have to do is think about equivalent fractions. So 3/10 and 30 hundredths are the same thing. So we just used equivalent fractions here to turn 3/10 into 30 hundredths. Now that we have a common denominator means the same denominator, we can add these two amounts, 30 plus 27. Now, if you can do that mentally in your head, wonderful. If you want to grab a calculator, you're welcome to use a calculator. You can also always come off to the side and write a vertical addition equation. 0 plus 7 is 7. 3 plus 2 is 5. What do you know? We have 57 out of 100. And that's what we got when we counted our diagram. So today you're going to be turning tenths into hundredths, then adding to find out final answers. So let's continue on and let's take a look at the visual learning page. So what your math book is trying to show you here is that Janet and Steve collected money for an animal shelter. Jana collected 5/100 of their goal. Steve collected 4/10 of their goal. And you see their amounts represented here. So obviously Steve, with the 4/10, completed a much higher amount than Jana with only 5/100. So what your math book is trying to show you here are the steps that you would go through. Here is your addition equation, but notice you have unlike denominators. The denominators are not the same. So we have to take the fraction with 10 and turn it into hundredths. And your math book is showing you the rule that we learned with fractions: whatever you do to the top, you do to the bottom. So to turn the 10 into 100, we multiply by 10. If we multiply by 10 on the bottom, we have to multiply by 10 on the top. So we turn 4/10 into 40/100. You don't have to show this multiplication step because we have learned that 4/10 is equivalent to 40/100. So in the end, after you find the equivalent fraction, you rewrite your equation so that you have like denominators, so that the denominators are now the same. Then you add to get your final answer. So you're going to try some of these situations today in your math book. On the guided practice section of the lesson, let's take a look at a few of these problems together. So today, we're going to skip problem number 1, and let's start with problem number 2. So write a problem that represents the addition shown below, then solve. So in order to complete problem number 2, let's look at the diagrams. Here in this first diagram, we see tenths. So let's write tenths as our denominator. And of those tenths, 9 out of the 10 have been colored. Now let's look at the second diagram. We see hundredths. So let's put 100 in our denominator. And out of all of the 100 pieces, we have 10, 20, 30, 40, 50, 60, 70, plus 1, 71 hundredths. So we know to find the total to add here, we would want to add these two quantities together. But remember, that's not going to work right now because we don't have like denominators. So we need to take 9/10 and turn it into hundredths. And we know that 9/10 is the same thing as 90 hundredths. Add that to 71 hundredths. And wow, that's going to give us a large answer. So I'm going to come off to the side and I'm going to add 90 plus 71. Don't forget, you're always allowed to go get a calculator. 0 plus 1 is 1. 9 plus 7 is 16. And we have 161 hundredths. Whoa, do you notice anything crazy about that? The numerator is bigger than the denominator. So remember, this is an improper fraction. Anytime you see an improper fraction, you want to try and turn it into a mixed number if you can. So 100 hundredths would be 1 whole. So we know we have 1 whole. If you take 100 away, that leaves you with 61. So we have 1 whole diagram. Oops, sorry, did not mean to be typing there. We have 1 whole diagram, and then another 61 hundredths. Wow, that one was a little insane. I promise some of the other ones are not going to be that crazy. So let's take a look over here at problem number 3. Now I'm going to show you a little shortcut. You know that 3/10 is the same thing as 30 hundredths. So you are allowed to just turn it into 30 hundredths right there. Then add those quantities. 30 plus 4 is 34 out of 100. So see, that one wasn't too bad. Look at number 4. Do the same thing. Find your tenths, turn it into hundredths. We know 5/10 is the same as 50 hundredths. Add them up. Again, this is a situation where he might want to use a calculator or write an equation off to the side. So 71 plus 50. 1 plus 0 is 1. 7 plus 5 is 12. My final answer is going to be 121 hundredths. But notice again here, we have an improper fraction. The numerator is bigger than the denominator. So let's decompose it. This would be a great time to be doing some of this work on scrap paper because you can see I'm clearly running out of room in my math book. So I know 100 hundredths is 1 whole. If I take that 100 away, that leaves me with another 21 hundredths. So if I'm going to turn this into a mixed number, right here is the 1 whole, and then right here is what I have left, 21 hundredths. So I hope all of that is making sense so far. If you struggle or have any trouble, please don't hesitate to reach out to your teacher for additional help. As you continue working on this page, the problems that we would like you to complete are as many of the ones on the bottom of the page as you can. On the back side of the page, we'd like you to take a look at number 24 and number 27.